Please remember on this review, they are numbered, but the numbers will not, I repeat, not correlate with the same numbers on the test tomorrow. So don't think number 1 on this is going to be just like number 1 on your test. I scrambled the questions. They will not be the same. All right, number 1. What are we supposed to be doing? Somebody look at that problem and tell me what you think we need to do. FOIL. That's exactly what we do. So it'll be 4 plus I radical 7 times 4 plus I radical 3. And you FOIL. 16 plus 4I radical 3 plus 4I radical 7 plus I squared radical 21. And that's what you should get. Now, looking at that bottom line, that doesn't look exactly like any of our options. Which answer is it, given what we got for our bottom line here? Very good. Very good. You might have to move your things around. All they did was they paired up the numbers without an imaginary number, 16 minus radical 21, and then they paired these two up and just factored out the I. They brought out the I, and then just put 4 radical 3 plus 4 radical 7. So it is C. Only if the, yes. Then you can add their coefficients. When you're multiplying, you just multiply what's under the rate, hence the radical 21 in this problem. Other questions? Adam, are you answering your question, or are you just thinking? Okay. Some of these will be 2-second problems that we can literally look at and just say the answers, and we'll move on. Other ones we're going to have to go pretty in depth with, so it's important we budget our time. Yes, sir. It is. But what is I squared? What is I squared? Negative 1. Negative 1 times radical 21 makes us a minus radical 21. Yeah, sir. Yeah, well, the negative 1, imagine this. Imagine this was negative 2 radical 21. You could write that as minus 2 radical. The 1 is implied, yes, but the minus came in with the negative. Yep. They just factored out the I. They said that's common. They could have factored out the 4 too, actually. In fact, it was kind of sloppy of them to take out one and not the other. It would have been better if they had factored out 4I and just had radical 3 and radical 7 in there, which may happen tomorrow as well. But that was the only answer that had anything remotely looking like what we had. So hopefully, even if you forgot those algebra little tricks, you could still make that conclusion. All right, number 2. Horizontal asymptotes. Raise your hand and tell me what we're looking for when it comes to horizontal asymptotes. What are we looking for here? This is a 2-second problem, if you remember. Close. Good guess. Yes. Highest exponent. Horizontal asymptote was, where's the highest exponent? Where is it? In the bottom. On that chart, if it's in the bottom, it's automatically 0. If it's in the top, there's none, and it would have been D. If it's in the bottom, it's B, because it's going to be 0. And if it's the same, you just cover it up and take the leading coefficients and simplify them. In other words, had it been 8x squared on the top, it would have been 8 over 2, which would have made it A, 4. There's 3 test questions just asking this. I think there's one of each scenario. So if you remember that simple little thing, that's 3 questions right there. Other questions about this problem? All right. All right. This one says, determine whether the function has a maximum or minimum, and then give that point. Now, easiest way to do this. What is the end behavior of our function here? Somebody show me with your arm. Up, up. That's right. Goalpost. Even, positive. Gives you up, up in behavior. That helps because if it's an up, you know you have a max or min. You have a minimum. Your parabola is going to come to the bottom. So you immediately know it's going to be A or B because it's a minimum. Now, once you know it's a minimum, you have to find, does anybody remember when we did this, it was the lesson I had to start over. Oh, wait a minute. Because the end behavior is up, meaning it has to come to a bottom. The vertex of a parabola will always be its max or min. Does anybody remember how to find the vertex? Yes! Love it. Negative b over 2a. Negative b is negative 2, 2a is 4, reduces to negative, and a is the only option with an x value of negative 1/2 that is also a minimum. Now, let's say a and b had the same x value. How could you find the y value? Plug it into the function. All you got to do. Questions on that one? Had, theoretical time, had this been a negative 2x squared, then it would have been a down, down, and it would have given you a maximum, and the answer would have been C. But it wasn't. So. Okay. Number 4, horizontal asymptote. Raise your hand and tell me what you think it is. Emily. Why C? That's very good. Same power, so you can take the leading coefficient, 3 over 3, negative 3 over 3, boom, negative 1. Good job. I apologize, that was awkward. Shouldn't have done that. Unbridled enthusiasm. Okay, questions on that one before I move on? Vertical asymptotes. What are we looking for when it comes to vertical asymptotes? Tyler Bursey, what are we looking for when it comes to vertical asymptotes? You know, I call on you all the time. I don't know why it is. I think it's the fact that Tyler Hale's always volunteering and Josh is always volunteering, and you're like in the vertex, of those two. So it just kind of feels like there's a void there. What are we looking for when it comes to vertical asymptotes? That's right. And what's going to make that equal to 0? 4 and what? Yeah, 4 and negative 4. Which one of these options is 4 and negative 4? That's right. Do not get this confused with what we did yesterday with the inequalities. Yesterday, yes, you would have needed 4, negative 4, and 0 to test your ranges. But when it just comes to vertical asymptotes, all we care about is what's going to make the bottom equal to 0. So don't be lured by C. Questions on that one?
So if the x is on the bottom and the b,
if those were flipped, it would just be 0. Because that would have been the only thing that made it 0 in the bottom. Other questions? I love if questions. Shows me outside the box thinking. If questions are fun. Number 6, just like one that we did last night. Alright, first thing we have to do, find where this thing equals to 0. Now, use your context clues. What do you think the roots are going to be just by looking at the answers? Okay, touche. That's not what I meant though. Looking at the actual answers, what do you think the roots are going to be of that function? Negative 6 and negative 2 are the only numbers that show up. Negative 6, negative 2, negative 6, negative 2, negative 6, negative 2. Don't do more thinking than you have to. Now, yes, if you don't trust that, even though I don't know how you couldn't because it's in every problem, every answer, you can plug them in. Plug in negative 6 and negative 2. Make sure they equal 0, and they do. So, the numbers you're checking are negative 6 and negative 2. You just need to check your ranges. Now, do we have any vertical asymptotes or double roots here? No, we don't. So I know all my checks and x's are going to alternate. So let's pick the easiest one to check. 0, that'd be over here. Plug in 0, that's 0 plus 0 plus 12. Is 12 greater than 0? Yes, it is. Check, x, check. There's no denominator. Yeah. Check X check. Which one of those is check X check? Well, darn it, again, I showed it. But, right. It says bracket, bracket, because there's an equal sign, less than -6, greater than -2. Do you have a question, Adam, or are you just typing stuff? This will be how your answers are. It'll be strictly, it'll have both for you. Now, I believe the next one that we do, 2 of these are the exact same, and you actually have to look at the domain. So it does give you both for a reason. Other questions? Use your context clues on this test, and it'll save you some trouble. Number 7. What do you think the roots are going to be? -1 and 8/5. That's right. -1 and 8/5. They show up like every single one. Here we go again. So, what's the easiest one to check here? 0. When in doubt, use 0 unless it's one of your roots. So if I plug in 0, well, let me rewrite this real quick as 5x squared minus 3x minus 8. Now that'd be 0, 0 minus 8. Is -8 greater than 0? No. X. I know these have to alternate because I don't have any double roots or vertical asymptotes. So which one of those is it? It is B. B has parentheses, implying that they are not included, but they are because there's an equal sign. So the answer is donut hole. Oh, I think I cut this one off. What? I have not. Are they good? Huh. Why does that matter? Really? Where's this? Then that one's my favorite. I love places that can't count. That's true. Don't ever go to the Taco Bell in Murray has great food, but like 7 out of the 8 times I've been there, they short me. I'll get like 3 things, and 2 of them will be in there every time. And my wife's just the opposite. I know what you're thinking. Is it just in her bag? No. When we'll go separately, she'll be like, I went to Taco Bell for lunch today. I ordered 2 tacos. They gave me 4 things. I think they just throw the food toward the bags, whatever lands. Yeah. That's awesome. Can I borrow those? I only brought $5, but I'm really hungry. That's cool. I didn't know you could get that kind of stuff. That's why you're an honest freak out, that kind of thinking. All right. Let's look at number 8. Number 8. I went to the game last night. I lost my voice. Okay. Touche. Touche. All right. What 3 values do I need to check here? Actually, it's +1, +3, and +2. It's what's going to make them equal 0. Well, then that one's wrong. We can cross that one out. But all the other ones, that one's wrong too. So I guess it has to be B or C. Yeah. So in this one, yeah, context clues can be misleading. Well, because R3, if you look at the problem, it's going to be 1, 3, and 2, and these both use the negatives, which don't come into play. So it has to be B or C. And then you can look at it as brackets. That's true. You could have gone with B without even doing any math here, couldn't you? It's dealing with brackets on the domain. But let's assume that the one tomorrow will not be quite Monday, will not be that easy. Okay? So you have to check your ranges. You plug these in. When it comes to these fractional ones, here's how I prefer to do them. You don't have to do them like this, but when it comes to a fraction being compared to 0, all that really matters is whether it's positive or negative, right? It doesn't matter if it's 0.1 or a billion. If it's positive, it's going to be greater than 0. If it's negative, it's going to be less than 0. So I'm going to plug in 0. If I plug in 0, that's going to give me a negative number, a positive number, and a positive number, which is going to give me in a big division problem what? A negative. Negative times a positive is negative. Negative divided by a positive is still negative. Is a negative less than 0?
Yes.
There we go. Now, is there anything that could plug into the bottom to make it negative? No, it's squared. You can't square anything and get negative, so we can just leave that one alone and just work with the top. What's the number between 1 and 2? 1.5. That would give us a positive and a positive, which is going to make the whole thing. Is a positive less than 0? No. What's the number between 2 and 3? 2.5. That'll be a positive, positive. That one doesn't work either. Remember, when it's an asymptote, all bets are off with the consecutive checks and x's or whether they alternate. Number greater than 3. How about 4? 4 would give us a positive and a negative. Is a negative less than 0? Yes, it is. So that's why it was less than 1, greater than 3. Now, this one, as it turns out, the vertical asymptote did not come into play with our answer. Had it come into play, remember, even though it's equals, it still would have been just a parenthesis, because you can't have something that makes the denominator in 0 equal 0 in your function at all. But since it didn't come into play, we didn't worry about it, and it's the one with the brackets. This one had parentheses, which was wrong. Questions on that one? No questions? All right. Number 9. Slant asymptotes. Don't worry about that little pin symbol. That's not the answer. Promise. Okay. What do I need to do for slant asymptotes? Oh, we didn't do this? Right. Oh, well then I'll just teach you right here. It really is very simple. If you want to kind of make a thing in your notes, I won't even make you do it on your homework. We'll just leave it on the test. It's really, when it asks for a slant asymptote, a slant asymptote is going to occur when the top is exactly 1 power greater than the bottom. Now, I didn't give you any tricks on yours, but if they weren't exactly 1 power greater than the bottom, then you can't have one. It would have been none. But I didn't put one like that on the test. So they'll all have one. So you can throw out the no slant asymptote option. But if your top is exactly 1 higher than your bottom, meaning you don't have a horizontal, you will have a slant only when it's 1 power. And you just need to divide using long division. And whatever your quotient is, that equation, that's your slant asymptote. Let's look at it. X squared minus 25 divided by x cubed plus 3. Here we go. X cubed divided by x squared is x. Multiply that back through. That's going to be 25x plus 3. Now, won't everything else be my remainder because it's smaller than this? Another awesome thing about slant asymptotes, the remainder does never come into play. You can chuck it out the window. So essentially, the only thing in our equation is x. Which one of these is that? A. Y equals x. Boom. Let's look at another one since I forgot to teach you that. Sorry. But, not a big deal. Now I know the next one I'm going to put up here can factor rather easily. I'll just do it on the same page. Let's pretend it doesn't. There's nothing to do. This is just a remainder. Because this is smaller than this. And your remainder you can just throw out the window. Litter it into society. Let's say, same question. Find the slant asymptote of, and I'm making this up, find the slant asymptote. It's exactly 1 power higher, so you know there's going to be one. So you need to divide. Yes, by all means do it synthetically if you get one like this tomorrow. But I don't think they are like this tomorrow as far as where it's just x plus or minus a number. So we're going to stick with long division for the practice. Yes. How many times is x go into x squared? X. Multiply back through. Subtract. You get 4x. How many times is x going to 4x? 4. 17, right. Did I do something wrong here? I'm going to make this a 16. Apparently I botched this earlier. I'm going to change the original problem. Alright, so I multiply that back through. Well, actually, it doesn't matter. I take that back. I'll just leave it as a 6. It don't matter. So I multiply that back through. You get 4x plus 16. This was really just a 6. And you get, when you subtract it, 0, negative 16, which is your remainder, right? Because it's smaller than x. So you can chuck it. So the equation for my slant asymptote will be x plus 4. It's just long division. Oh, right. Touche. I was just so anxious to throw it out the window. I forgot to think. There you go. But regardless, when you're finding slant asymptotes, your remainder doth not matter. Doesn't come into play at all. Your slant asymptote would just be x plus 4. That's it. So if you want to write somewhere on your notes, slant asymptote equals long division, done. And throw away remainder. And that's it. Question? Long division. Throw away your remainder. Literate. Alright. How we go? Dang it, I botched this one. Because I made it like the one that was your bonus. So I'm actually going to scratch this and we're going to make up our own problem. Let's say n equals 4. And let's see, let's go with 2, negative 3. And let's say f of 0. Don't write this last part yet. I'm not sure if it's going to work out because I'm making it up. But here's the problem it's going to give you instead. Oh, what am I saying? I'm sorry, I shouldn't put that like that. And let's say 2i. 2i. So it says, find a degree within the polynomial. Here are the numbers you need to use to get it. So it's going to be x minus 2, x plus 3, and x plus or minus 2i. Don't forget, we're also going to have to solve for this mystery variable a out here, but we're going to do that last. So we start foiling. Yes, although don't write that down just yet. I'm going to make sure that that works out first. So we keep foiling. I beg your pardon. What? Hot diggity dang, I think this is going to work out. You sound like my arch enemy when you say something like that. You got lucky, but I'll get you next time, Ryder. Like I chose Tangled Ryder. I was like one of the Stabbington brothers. You guys obviously just don't know as well as I do. All this time. Alright. Yes, actually. So, once you get your function, plug in what it says, 0, into the function, and what are you left with? You're left with, when you plug in 0, you're left with negative 24, and you set that equal to negative 48. You divide. What is negative 48 divided by negative 24? 2. So you come back up here, and you multiply that back through. 2x to the 4th plus 2x cubed minus 4x squared plus 8x minus 48 would be your answer. Backwards. Take this one over here. Solving for a. And then you take that number, and it should, if you do it right, it should be a nice rounded number. 2, 3, negative 2, 1 even. It won't give you a 0. That'd be weird. Well, actually, that becomes your phantom A value, and you actually, for your finished product, would multiply that through by everything. And that equation, once you did that, would be your answer. Plus, yeah, all the way through. Yeah. Other questions? Questions? Oh, while I'm thinking about it, raise your hand if you've been borrowing my calculators lately. It's not a problem, but if you've been borrowing my calculators, please make sure you bring those back before school. I have other classes that use those. Thank you. Questions about this problem? When you FOIL? Yeah, I kind of skipped that step, didn't I? Whenever you get an imaginary, that basically means two roots, right? So it's always going to be x plus that imaginary and x minus that imaginary. Whenever it's like that, it'll always turn out to be x squared plus this number squared. It'll end up being x squared minus 2ix plus 2ix, cancel, minus 4i squared, which is negative 1, minus negative 4 plus 4. That's why it's always going to work out. Other questions about this problem? Well, that's for you to decide. Alright, use the leading coefficient test to determine the end behavior. You could multiply everything out, or when it comes to the leading coefficient test, the only thing that matters is the leading term, right? So how many x's are in this problem? 4, that's right. I appreciate you saying something. 2 here and 2 here when you FOIL. There are 4 x's, so I know it's going to be even, so I know it's going to be up, up, or down, down. When I multiply that whole thing through, think about this. When I FOIL this together, I'm going to get x squared, we'll say x plus 2 squared, leading term x squared, right? Then I'm going to take that, and I'm going to FOIL it to this one. X squared times x squared is going to give me x to the 4th, my new leading term. Multiply that by negative 5. Negative 5x to the 4th makes it negative even, down, down. Falls to the left, falls to the right. And the answer would be A. When in doubt, if you don't like to do that kind of thing, and by all means you may not, just FOIL it all together, and you still would have gotten a long polynomial with the leading term being negative 5x to the 4th. It's from that chart we did?
Yeah, I remember that. But it's a parabola, right?
Sure.
And then
A negative parabola.
Yeah, this is kind of like that. How does it fall to the left and fall to the right?
So you're agreeing that it looks like this.
Yes.
Falling to the left, falling to the right, down, down.
From the break point? Or where it meets?
No, you're thinking about it in terms of the middle of it. When it comes to end behavior, the only thing that matters is like what it's doing at the ends. Like, is it shooting off toward infinity or negative infinity? And since they're both going down, you would say it falls. Okay. Other questions about this one? When in doubt, FOIL it all together. That would be one. This is a perfect example of one. If you were to FOIL all that up tomorrow and make one little mistake and accidentally pick the wrong one, if you showed that on your work page, that'd be worth most of the points back right there. That's a good example of one you should definitely show your work on. Okay. We're going to skip that one because I botched it. Although, I will say this. There is a chance. If one shows like this on your test, I will precede that test by saying it's a bonus. Because what we found last block, this is not an impossible problem. We factored out an x, meaning we have a 0 root. And then we had, I think it was 4 minus x squared minus x to the 4th, which we then rewrote in frontwards order. And we took our p's over q's, and we thought, let's find other roots. And it turns out none of them worked, meaning they were all either irrational or imaginary. So without doing an XY chart, the closest we could approximate it was B, C, or D, just by the behavior and the fact that it goes through 0. You could do an XY chart. That'd be the easiest way to solve this one and find which one was accurate. We're going to do another one like this that's much more doable, but you may have one like this on your test on Monday that'll be a bonus, and where you just have to make an XY chart and be really precise on your graph and see which one it was. But it would just be a bonus, so don't fret over it. Here would be one like you'd have on your actual test. What are my roots? Awesome. 2 zeros, 1 4, 1 1, which means it's going to touch at 0 and bounce at 4 and 1. So, well, also, what's my end behavior going to be? Nice, down, down. There are 4 x's, and it's going to be negative. So down, down. So which one of those is down? Actually, that's the only down, down on the page, isn't it? So there you go. But nonetheless, it still touches at 0, crosses at 1, crosses at 4. Now, let me reiterate something I said a second ago. When I said you might have one like this that's only a bonus, I'm not saying that all the ones you have like this are going to be nice and factored for you. But all the other ones, all of these that you have that you're required to do, you'll be able to find the roots for it, either by doing p's over q's or factoring or however you want to do it. So any graphing problem you have, you can do what we've been doing. Find the zeros, etc. Questions about that one? Okay. Long division. Long division. Actually, you know what's interesting about this? We're going to go ahead and do it long division style. But if you had noticed, hey, I can factor a 2y out of everything, you could have reduced it to something you could have done synthetically. Kind of nifty. Calm down. We'll look. The point is, another things you can look for. I don't know if this is going to come into play on your test or not, but like you could have noticed, hey, 2 and y. Oh, nope, 2 doesn't go into this one. Never mind. But y does, so you could have simplified it before you did it. But nonetheless, let's just do it as is. 2y squared plus y divided by 8y to the 4th plus 12y cubed plus 0y squared minus 2y plus 0. 0. Alright, this divided by this is what? 4y squared. Multiply that back through. Subtract. So was it 8y cubed? Nothing really comes down, it's just a 0. So this divided by this, 4y. Multiply that back through. That's 0. That's 0. Come on. Okay. We're almost done for crying out loud. Minus 4y squared. You can bring down the 2y. How many times does this go into that? Negative 2. Multiply that through. Heck, yes. So let's go ahead and finish it. Subtract again. Everything cancels. Nothing to come down. So there wasn't a remainder. So yes, it would be C. If there was a remainder, who can tell me how I would write that? Yeah. Yeah, just how would I write the remainder? Exactly. Exactly. Now, I would think it would always put a plus in front of it should that be relevant tomorrow and Monday, and it very well could be. Please note, if they put a minus next to it, that doesn't just imply that the top was negative. That would have to distribute in a very funky way. So hopefully it'll be a plus. But if you can't find it Monday where it's plus your remainder, then what they would have had to do is, let's say our remainder was 2x, negative 2x minus 1. Okay? Let's say your remainder was negative 2x minus 1. So, well, I guess we'll use y since that was what was given in the problem. If you're going to put a minus sign with your remainder, you're going to have to factor out of the entire numerator. So that would be the same as minus 2y plus 1 over whatever you were dividing by. So it would have to distribute to both things. So if that comes into play, please remember, if it's a minus in front of your remainder, it has to distribute throughout the numerator. Of course, that wouldn't apply here because there's only one thing. But anyway, let's just keep going. I'm talking. All right. I'm giving you the first one. You just have to use that, take it out, and find the other two. What do I need to divide by? -7, which means I can immediately cross off which two options? That's right, because they don't have a -7 in them. So 1, 15, 71, 105. Drop the 1, multiply. Add, multiply, add, multiply. Yay! You get this. You could do it however you want. You can factor, you can do quadratic. I think quadratic is the easiest way to go. That's -8. 64 minus 60 is 4. Square root of 4 is 2. -8 plus 2 is -6. -6 over 2 is -3. -8 minus 2 is -10. -10 over 2, -5. So it would be D. Yeah, I know, but you may not be able to tomorrow. In fact, the next one you won't, because I made sure to put one with imaginary answers. In fact, that's why I did it too. I put one in there with imaginary answers so that you would have one at least that you had to do those steps. Questions? Okay. The next one, same thing, except they don't give you the factor. They give you the root, like exactly what the root is. So you take it out verbatim. Drop the 2, and here we're off to the races again. Plug this into the quadratic. I trust you can do that. We've been doing that so much lately. You punch 2, -3, -5 into the quadratic, and you get your other two options. If you want to know if you were right, if you are working on this later, I believe it was not that one. No, oh, there it is. I don't know. There it is. It was B. You can finish it up. Just quadratic. Okay. 17. Find a rational zero. So, this one you have to do P's over Q's. But again, your P's over Q's are going to be 1, 3, 13, 39, and then 1 and 2. But context clues. It's going to be either positive or -1 or positive and -3/2. Those are the only options it gives you that aren't imaginary. So let's try those. Which one you want to try first? 1, -1, 1. Okay. +1. Stop thinking. Let's try it. Now, you can just plug it in to try it, but remember, you're not going to have those handy-dandy calculators, so I think it's easier just to use synthetic. Drop the 2, and we're off. I disagree. Boom! Worked! Yes. So it's going to have a +1 in it. So this one's out and this one's out. Yeah. So we still need to know whether it's positive or -3/2. Which one should we try? Try the negative. Here we go. Let's try the negative first. Hopefully it'll work. If not, it'll obviously be the positive one. Drop it. This times this is -3. -18 divided by 2 is -9 times -3 is 54. Holy mackerel. Normally when you come up with an ugly number, probably not the right one. But we'll keep going. 98 over 2 is 49. 49 times 3 is -147. Yeah, this is not 0. Maybe. Shut up. Yeah, you're right. You are correct. And I'm wrong. Feels good to hear him say that, doesn't it? 71. Oh, that's even worse. That's extremely prime. So this is going to be ugly, not 0. Which is good. We know that one wasn't it. So let's try 3/2. Let's try positive 3/2. Well, that's kind of cool looking. Remember, you take it out of your depressed. So 2, negative 15, 44, and negative 39. Drop the 2. Negative 12 over 2 is negative 6 times 3 is negative 18. 26 divided by 2 is 13 times 3 is 39. Hot diggity. We found the other one. And then you punch those into the quadratic formula. Oh, is there? Oh, yeah. Now we don't know which one it is because that's positive. So you need to punch that into the quadratic formula. Oop, negative 12. So positive 12. B squared minus 4A. Yes, but on your test it may not be that simple. So I want you to get used to finding those imaginary answers. So that's 12 plus or minus, yikes, 500 and 208. So that's negative 64, which is 8i, which would reduce to what? That's right. So that would be, again, D. But you may have to find those because it may be the same for those two. So you would need to go ahead and finish finding your imaginary ones as well. We're almost done, which is good, because I only have a little bit more voice power left. Number 18. Oh, just list the P's over Q's. I'll let you do this in your head and somebody just blurt out the answer. Other than Josh. So what's the answer? Didn't that say not that? You're right. P's, positive and negative 1 and 3. Q's, plus or minus 1 and 7. So, when you set those up as fractions, that'd be 1, 3, 1/7, and 3/7. That would be D. P's over Q's. Last one. Intermediate value theorem simply states if you have two numbers and you plug them in and your y values are different for those two, then there has to be a root between them. Some of you got point deductions on your last quiz that I'm handing back tomorrow because when you had this problem on your quiz on Monday, for those of you who are here, when you punched in 1 and 2, you got like negative and positive, which did imply a root, but you didn't say that it implied a root. And it clearly says determine whether or not you have a root or not. So it's a yes or no question when it all comes down to it. So we need to plug in 1 and 2. Again, you can plug it in, or you can use synthetic division, take your remainder. It's the same thing. Without a calculator, I'm going to prefer the synthetic. I plug in 1. It was really creepy. 13? That's not right. Oh my goodness. Oh, that's a negative 8, isn't it? I couldn't figure out what was going wrong here. Okay, negative 3. So I can immediately cross off A and B because they don't give me negative 3. So now I just need to find what 2 is. Now remember, we're not solving for the zeros here, so you don't take it out of your depressed, you take it out of your original again. Or again, you could just plug it into the equation, but I think this is easier to do. That's just me though. Drop the negative 2, 6, 12, 9, 15. So, is there a sign change? Yes. Yes. So the answer is C. Negative 3 and 10, there's a sign change, so yes. Yes, you absolutely can. Just, and 1 and 2 is not bad, but tomorrow you may have things like 4 and 5, which may be a little uglier. So I thought, I wanted to remind you that you could also do this in case you don't feel like, because you're not going to have TI calculators tomorrow. Any questions about any of the problems that we've done? Would somebody like to see another part of any of these problems? Okay. Put those up. Your only job this weekend is to prepare